So when we're adding with unlike denominators, our first goal is to get the denominators to match, and then we can go back to like we were doing before and just add the tops together. So looking at part A here, we've got a 2 over 15 plus 4 over 21. So we need to make them to where they have the same denominators. So I'm going to go ahead and kind of set this up here. But I got to find a number that's divisible by both 15 and 21. So let's think about finding the LCM between 15 and 21. Looking at finding the LCM, it's been a bit, right? So I like to just break those down. I mean, like I know 15 is 3 times 5, and I know 21 is 3 times 7. So as an LCM, it's got to be the numbers that are involved in any of them. Okay. So like the 3, they both have that in common. Well, I only have to write it down here once. Are there any other numbers up there? Yeah, there's a 5 and there's a 7. So I'm going to need both of those. So it's not only what they have in common. It's not that idea. It's the one that says what's involved in any of them up there. So our LCM is going to be 3 times 5 times 7, which if we drag out a calculator and do 3 times 5 times 7, that's going to give us a 105. Okay, so we're going to want both of our denominators up here to be a 105. But we got to build to get that. Okay, so like this first fraction started with a 15, which we know is 3 and 5, 3 times 5. So all I got to do is get that extra 7 in there. So I'm going to take the original 15 and I'm going to multiply it by 7. Now, whatever I do to the bottom of that fraction, I also have to do to the top. Okay, so that 2 that's up there, I'm also going to have to multiply it by 7, just so we can keep things fair. And what you're going to see is that 15 times 7 gives us the 105, like what we needed. Okay, we're going to do the same thing to that next fraction. 21 is the 3 and the 7, but we were missing the 5, right? So let's take that 21 and multiply it by 5. Whatever was on top, we've also got to multiply it by 5, just to keep things fair. So that should make 21 times 5 become our 105, and now our denominators match. Okay, so we're ready to finish this up here. 2 times 7 is a 14, 4 times 5 is a 20, and now that you have matching denominators, you can add the top and leave the bottom as a 105. So we're really looking at a 34 over 105. And we need to think about reducing that if we could, but 105 is going to be divisible by 5, but the top is an even number. It's going to be divisible by 2, so that's as far as that one's going to get to go. Now, looking at part B, we threw some negatives in here. So let's see, we've got a 2 over negative 3 plus 1 over 5. I'm going to go ahead and move that negative to the top. I'm not used to seeing it sit in the bottom, so let's just make it a negative 2 over 3 plus 1 over 5. And that'll kind of help clear up our, matching the denominators like we want them to be. So our LCM between 3 and 5, I think it's going to be 15, right? Something that's divisible by both 3 and 5 is 15. So it's not quite as complicated as this one up here. These were not prime numbers. They broke down further. But 3 and 5 are both prime numbers. So just multiply them together and you've got your LCM. Okay, so we want our fractions over here to match, and so that they both have the 15 in the bottom of them. Okay, well, what do we have to do to 3 to get 15? We multiply it by 5, and we also have to do that to the top. Okay, what do we do to 5 to get 15? We do a 5 times 3, and we have to do that to the top just to keep things fair. Okay, so we're looking at a negative 10 over 15 plus a 3 over 15. And when you add negative 10 plus 3, I'm still on your paper. All right, so negative 10 plus 3 over the 15, we should wind up with a negative 7 over 15. Again, simplify if you can. Like if that was a negative 7 over 14, we could call it a negative 1/2. But 7 and 15 is not going anywhere. And now looking at C and D, we're starting to put some variables in our denominators. Okay, so it's still the same idea. It's just working with our variables now. So let's look at part C. Part C tells us that we want to do a 3 over x plus 4 over y. So just like before, we're going to hunt down our LCM, and we're thinking about something that's divisible by both x and y. Okay, something divisible by both x and y. Well, it's not like I can break down these composite numbers into a list of their primes. None of that's going to work. What if we just say our LCM is xy, right? X times y. xy is divisible by x because it's got an x in it. xy is divisible by y because it's got a y in it. Okay, so it's kind of the same idea of what we did back here with that 3 and the 5, and we said, well, just multiply 3 times 5 and get your LCM of 15. Okay, same idea. We're just going to go ahead and multiply that x and y and get the LCM of xy. So our fractions over here, if we're going to get x to become xy, we have to multiply it by y. So you have to do that to the top as well. And our next fraction, to get y to become xy, we have to multiply it by x. So we have to do that to the top as well. So we're really looking at a 3y over xy plus 4x over xy. Now, I know I switched the order there, but multiplication is commutative, and you can do that. That's allowed. So once your denominators match, you simply add the top and stick it over your xy. Now, previously, we were doing that. We were saying, our negative 10 plus 3, we put it all in the top part of the fraction, and then we take it a step further and actually add or subtract it. We can't do that on this one because our variables are not the same. Okay, so we can't take that and call it a 7xy. Okay, in order to add or subtract with variables, the variables have to be the exact same and the same powers. So this one's not going any further. That right there is your answer. So now let's look at some with powers. They are both a's and b's, but do you see that the squared is in different places, right? This first one has an a squared b. This is ab squared. So what does that mean for your denominators? Well, here we go. LCM. This one, it may be helpful to actually break it down. Okay, those are not prime variables. Okay, you could think about it as an a times b, and this one is an a times b times b. Right? Does it help you see it a little bit more clearly there? So I want to take you back to what we did on part A. So when we had composites earlier, we said, the 3's were both, the 3 was in both of them, but we only had to write it once, okay? The 5 was missing, the 7, we had to have everything, but if there were any kind of repeats, we didn't have to have them. Well, that's opposite when it comes to the variables, okay? So like you see how we have double A's here, and over here we just have a single A. For the LCM, you've got to have double A's, okay? The B's, we only had a B here, and then we had double B's here. We're going to need double B's for our LCM. Okay, so it's backwards for the variables. You do have to have multiples up there. All right, so let's get our common denominators happening. So we have, for our first fraction, the a squared b. I've got the a squared down here, but I do need an extra b, right? So let's take that a squared b and multiply it by b. And we've got to do that to the top as well. Whatever we're multiplying extra into it, we've got to do that to the top. Now over here, we've got our 3 on top, and you've got your ab squared. So I've got the b squared, and I've got an a, but I'm going to have that extra a. So let's multiply by an extra a. Alright, so what are we looking at here? We've got a 2b over a squared b squared, and we've got a 3a over, when you do an a times a, that gives you a squared. So a squared, b squareds match. We can add the top, keep the bottom the same, and I think that's as far as we can go, right? We can't add or subtract those top pieces anymore because they're not like terms, okay? B versus A. So that's as far as that one's going to go.